Hello everyone, my name is Wanyu. I'm from Harbin Institute of Technology, Shenzhen University. I'm very happy to have this chance to give my presentation. The topic of my presentation is a biofeedback process detecting architectural space with the integration of emotion recognition and eye tracking technology. I'd like to divide my presentation into 4 parts. In the first part, I want to introduce the background of this research. The second part looks into some related researches. The third part covers our research object and method. Finally, summary and future work are given. Well, let's move on to the first part of this topic, the motivation for this work like this. In the future, designers must study the influence of not only the built environment on people, but also people's feedback on environmental design. I want to use a picture to illustrate it. As signals, environmental elements can arouse users' perception through visual, auditory, haptic, and finally form feedback suggestions about the space for designers. The user's physiological and psychological feelings are essential criteria for designers to evaluate whether the design of the built environment can meet the needs of users. Yet, there are limitations in applying biofeedback in the design of architectural spaces. The problem is mainly reflected in the following 2 aspects. On the one hand, the traditional spatial design's feedback relies on 2D drawings or abstract text descriptions. With digital tools, designers also start using the 3 models, but only to show the architectural visual outlook, and without interactivity with the users. Users can't intuitively understand the architectural design and provide accurate feedback. On the other hand, designers are able to capture the spatial perception of users through subjective descriptions. With the development of information science, technologies now play an important role to collect and analyze such data. This picture shows some hardware that can accurately measure real-time physiological data and obtain cognitive feedback of the space from users. The physiological data can include eye tracking data, electroencephalogram, peripheral physiological signals such as galvanic skin resistance, blood volume pressure, respiration pattern, skin temperature, electromyography, and so on. So yes, this method can provide an auxiliary way for non-architectural professional users to participate in architectural space design. So consequently, the scientific question of this research is exploring the process of interactive design using both emotion recognition and eye tracking of users. By putting on wearable devices to roam and perceive in a VR space, the physiological data of users are collected in a real time and used to analyze their emotional response and attitude to the spaces. To achieve the aim of this research, it is important to look into some related research on emotion recognition, eye tracking, and focus on analyzing relevant indicators and data processing methods. The premise of interactive design is that designers can collect and analyze users' physiological signals in the process of space perception. So let's move to the first related research. DEAP databases is a public database for emotional analysis based on physiological signals, which was first presented in 2012. The experimental study used music radios and effective emotional stimuli materials. and physiological signals were collected while watching videos. The research of DEAP databases gave us some experience about the collection of subjective and objective data, and understand the different reflections of several level physiological signals on emotion. The second research about emotion recognition is a study conducted by DIAS in 2014. They use a semi-immersive VR system to show several types of spaces and captured subjects' electromyography and electrodermal data as indicators of physiological signal testing. Okay, from this research, we can learn that with physiological signal testing, the designers can objectively discriminate arousal response related to positive or negative emotions when users are in VR spaces. After analyzing a variety of physiological signals to understand users' arousal and emotion in visual spaces, we can use eye trackers to know more information related to spatial cognition, even which users can't describe. I'm going to introduce two studies related to eye tracking and spatial perception. The first research is presented in 2014, which combined with mobile eye tracking systems for wayfinding studies. They get the visual attention of all participants through 3D visualization and help identify the most compelling elements of the space. The second study is an integration of VR and 3D eye tracking to redesign street space. This study used software to collect the spatial activity data is on the visual sense and provide the 3D point cloud data of spatial behavior. Eye tracking data shows that the professional subjects paid more attention to the second floor. However, native subjects paid more concentrate on the colonnade, barked arch, the lantern, memorial arch, pelagic objects. From these cases, we know that the combination of eye tracking and virtual reality will have a broad application prospect in the research of architecture space. By processing the primary eye tracking data, some meaningful indicators can be obtained from the evaluation of architectural space, such as height distribution, line of sight, and 3D spatial wind point distribution. Okay, after analyzing the related studies, I will introduce the object and method of our leading research, which in progress. In our research, we analyzed the exterior exu space of the new International School of Design building in our university. This site of ISD is between the main entrance of the campus and the tall administrative building, which representing the spirit of the school. The designer made an issue space. Hope this can become a dynamic exercise where people gradually enter the university and can feel academic atmosphere of the school. This research aims to get the user's perception feedback of this outdoor space in advance, which could help the designer to check whether the existing design meets the requirements of this space. Having ISD as the research object, we will first build the visual simulation model of ISD. And then, after recognizing the evaluation subject space and comb the spatial, we will organize participants to put on both VR eye tracker and wearable physiological signal distinction equipment to roam and perceive the virtual space. By integrating the corresponding relationship between the emotion data and spatial data, we can understand the key positions and time points of emotional arousal of participants, and analyze the eye tracking to understand which visual elements cause emotional arousal. So let's move to a summary. In this paper, we review existing related research and proposing an interactive design workflow that integrates eye tracking and emotion recognition. It can be seen that the combination of emotion recognition and eye tracking feedback can better meet the need of spatial perception feedback. Although it is still challenging to determine the special emotional types of users, designers still have the opportunity to understand the special emotions of participants in combination with subjective surveys. In the future, we will organize participants to complete the experience evaluation process with the International School of Design Building to improve the applicability of this interactive design workflow. And the building will be completed in 2 years. We will then be able to gather another set of data to analyze whether the current understanding truly reflects the user's needs, and whether the integration of two technologies is feasible. That then was all I want to say about my research. Thank you for your attention.